Writing quadratic equations in vertex form is one of the most challenging concepts for students in Algebra 2. And in this video, I'm going to be showing you step-by-step guide on how you can do that. I'll be using the equation y equals 2x squared minus 3x plus 5 for everything that I'm going to be explaining in this video. Now, the first thing we have to do is that, as you can see, we have the equation written here, y equals 2x squared minus 3x plus 5. So all we have to do first is to isolate the terms that have x from the terms that are constant. So in this place now, we have 2x squared minus 3x. Those are the two terms involving x, and we have a constant term plus 5. Now, when we are done with that, the next thing we want to do is that we want to ensure that the term that is with x squared is standing alone without any coefficient. In this situation, we have the coefficient of x squared to be 2, so we need to factor out the 2 from both the term with 2x squared and the term with negative 3x. That's exactly why we needed to isolate it, as I've put this in the box here. So to factorize 2 from this, when you factorize the 2, x squared will be standing alone minus. Now, to get what is going to be, because 2 is not a factor of 3, so when you're factorizing 2 out of 3, you don't necessarily get a whole number, just like in the case of 4. If this was 4 now, if I'm factorizing 2 from 4, you would know that what will be left in the parentheses is 2 as well, because 2 multiplied by 2 will give us 4. But we can use the idea to also get what will be left in the parentheses after we have factorized 2 from 3, because whatever is going to be left, if we multiply the 2 back with it, it should give us these 3. And that's what I've just expressed here. You realize that if you multiply 2 and 3 over 2, that would definitely just cancel the 2 out, and you have 3. So similar thing you can do. Let's say, for instance, this was 4 and this is 7. So if we have 4 here and we have 7 here, so if you're factorizing 4 out, that implies that what will be left here will be 7 over 4. And you can generalize that for any case that you want to do. So let's go through this again. Factorize 2 out, we have x squared minus 3 over 2x, then we have plus 5, which is our constant term. And when you're done with this is where you complete the square. For you to complete the square, there is a term that is very, very important, which is the term that is the coefficient of x. And here we have that as negative 3 over 2. Negative 3 over 2 is our coefficient of x. Now, to complete the square, we will need the square of half of that guy, which is negative 3 over 2. So which is what I'm doing here, half of negative 3 over 2. Half of negative 3 over 2, it's simply 1 over 2 multiplied by negative 3 over 2. This is the term that we need to complete the square. Don't forget that. And when you do that, you get negative 3 over 4. When you've gotten negative 3 over 4, the next thing you want to do is that you square this result, you add it to the term that you want to complete the square. However, when you add this term, which is negative 3 over 4, as you can see, I've shown it here. This is 2, this is x squared, this is negative 3 over 2x, so I'm adding the square of negative 3 over 4 now. The problem with this is that if I should do that, that will be changing the question completely. So I have to bring in something that will counter that effect, such that it will be as though I'm not adding anything at all. So as I'm adding the square of these, I have to subtract the same thing as well. These two, they have the same value. Hence, I can say that adding and subtracting is like I'm not doing anything to this whole expression here. It's just like adding 0. And the reason we do that is so that we don't change the question completely. If it were to be like we're solving equations such that something is on the left hand side, another thing is on the right hand side, we can just add this to the thing we want to complete the square, then we add the same thing to the other side of the equation just to balance things out. And that is what that is. So I believe you understand what is inside the parentheses here. And we still have our constant term, which is plus 5. Then when you are done with that, you realize that these 3 terms, they can be factorized such that you just pick the x from this place, then you pick the negative 3 over 4 from here, so you put them together in a parenthesis, then you square that. If you expand this, you get these 3 terms back. Yeah, expansion of these will give us those 3 terms back. And then we have a negative sign here, so we have minus. Then you have to evaluate this. Negative 3 squared is 9, and 4 squared is 16. So we are getting close to the result. Plus 5, it's still there. And the next thing you want to do here is that you want to expand this bigger bracket. You want to expand it with the 2 that is outside here. So we have 2 multiplied by the whole of x minus 3 over 4 all squared. Then minus 2 multiplied by 9 over 16. Then you just factor out the 2 in 16. Then you have 8 left. So 2 multiplied by 9 over 16. That's going to give us 9 over 8. So you have minus 9 over 8. Then you have plus 5, which is the constant term. Then the next thing you want to do here is that you want to perform this fraction expression, negative 9 over 8 plus 5. If you do the needful there, you'll get a plus 31 over 8, plus 31 over 8. So this term still remains the same. Now, we have successfully written this quadratic equation in vertex form. And what we need to do now is to compare with the general vertex form of the equation, which implies that h will be 3 over 4 and k would be 31 over 8. So this equation in the vertex form, h comma k, the h is 3 over 4 and the k is 31 over 8. Of course, a is going to be 2 here. And then whatever the sign of a is, if a is a positive value, it implies that we have a parabola that is curved upward. And if a is a negative sign, we have a parabola that is curved downward. And that's basically what you need. So if you want to see more algebra content, pre-calculus, calculus, or anything math and physics at all, you can hit me up via the number being displayed on the screen on WhatsApp, and you can also reach me via my email. I'll see you in the next one.